The last class we were discussing much about, we did all the preparation of alkenes, right? Let's start with properties of it. Along with E1, E2 mechanism, E1 CV mechanism. We did that, right? Manch?
Yes, ma'am.
Any doubt in any parts of art, Himansh? Want it first?
No doubt.
Let's discuss now the physical properties of it. So first physical properties are the physical state and smell of it. So first three members, three alkenes. Start. What are the first three members? Ethene, propene, and butene. These are the first three members. The first three members are gases as normal temperature. Alkenes up to 5 to 18 carbon. They are liquid in nature. And the higher member of the family are solid in nature. All the alkenes are having their nature color to be. Ethene is colorless gas. Ethene. This is a colorless gas with faint sweet smell. All the other alkenes are colorless and odorless. Colorless and orderless. Melting point. So while discussing about the melting point of them, we will say that in generally melting point of alkenes is higher than alkenes. What the reason behind it is? Because these alkenes contain pi electron cloud. So pi electron cloud is more polarized. More polarized.
No, you can say more bonds will be 3 bonds. That's why.
Huh?
No, you
Bonds.
more bonds. There will be 3 bonds. No, 2 bonds. No, then that's why we can say.
No, that is not the reason. See, if the pi electron cloud is loosely bound as compared to sigma electron, the difference between alkenes and alkanes is like this only, that they are contained in alkene there is pi electron cloud, in an alkane there is sigma electrons. So pi electron cloud are loosely bound, right? So it can easily polarize. Correct? Just like we can transfer the pi bond to any one carbon, so we can say poles will be created. Positive, negative poles will be created due to relocation of pi bond. But alkanes cannot transfer that sigma bond because it's very strong, so it cannot be shifted from one side to another side, right? Got it or no?
Yes, ma'am. Got it, ma'am.
That is the ultimate reason. That alkenes are having pi electron cloud, it is more polarized, so the policies are very much high in them. Okay. Also, melting point will increase with the increase in molar mass. Also, melting point of trans and cis. Which one is high? Trans is having high melting point.
Ma'am, because less repulsions, we can say the reason.
They are symmetrical, so packed very easily. Packed more. Right? Now boiling point. So boiling point directly proportional to molecular mass as well. Right? For each CH2 group added, we can see a 20 to 30 degree rise. Right? Symmetrical isomer alkenes like cis and trans. So in between cis and trans, the boiling point is YF6 as compared to trans. Because in cis there is more polarity, right? Dipole moment is there. Okay. More polarity means more dipole-dipole interaction. With more dipole-dipole, so it is having more boiling point. Is it clear or no?
I'm clear, ma'am.
Also remember that boiling point is inversely proportional to their we can say branching. Boiling point is inversely to branching. More the branching, lesser will be the boiling point. Then is dipole moment. Dipole moment is alkenes is having more dipole moment as compared to alkenes. So cis and trans. This is having more. The trans is almost zero dipole moment, we can see. Due to opposite direction, their dipoles are oriented, right? Let's CH3, CH3, H, H. CH3. So here what we will say, Himansh, that CH double bond carbon are electronegative, so it will take that electron. Here it will be like this. So we can say dipole moment in this compound trans 215 is 0. But here it is greater than 0. Although small, but yes, it contains dipole moment. But if we are having, let's say, trans, but dissimilar, H3 to H5, CH3, H and H. So here dipole moment is greater than 0, very little. Right? Okay. And now Himansh,
I'm not okay.
solubility. They are lighter than water. Insoluble in water, as they are non-polar. That's the reason. But they dissolve in organic solvents like alcohol. Dissolve in organic solvents like alcohol, benzene, or alcohol, benzene, ether, CCl4. These all are organic solvents. Okay, we have already discussed that topic now, stability of alkenes, heat of hydrogenation or no? Himansh, remember or not?
I miss ma'am. Sleep.
You did that?
Which topic, ma'am? Heat.
Heat of hydrogenation. Stability of alkenes, that heat of hydrogenation. We did not this topic. See, stability of alkenes. We did that.
Yes, ma'am. Stability process we did, ma'am. Which will be.
Okay. So after that, let's discuss now with chemical properties. See, alkene contains pi electron cloud. Right, this pi electron cloud is electron rich. So easily a nucleophile can attack over here. Nucleophile is, electrophile, that is electron loving compound will attack over there. So we can say it undergo electrophilic addition reaction. Electrophilic addition reaction. Got it? So let's say we are having a double bond like this. What will happen? A, B. So A, B are the attacking molecules. They will be attacked in a manner that now A over here and B over here. This is the addition product which we are getting. So apart from overall, it will do addition reaction, oxidation reaction, polymerization reaction, some replacement reactions of alkyl group. Let's discuss them one by one. First of all, we are going to addition reaction. Addition reaction. So what happens over here is step number 1, where we are having, let's say, a double bond like this and AB. Partial positive, partial negative. So let's say bond migrates over here over to this carbon. This carbon over tap over to electrophile. Right? So first of all, electrophile here a positive charge will come. Over here electrophile, that is A, attacks. Finally then B, that is a nucleophile, it's attacking on the second step. Second step, what happens is that this carbocation is being approached by the nucleophile, B negative. So we are getting this.
No, means the electron, this carbon takes and it forms C plus C minus, and the C minus and this A plus will combine. We are again saying, ma'am.
positive, partial negative. What happens over here is bond, let's say, migrates over here. Due to that migration, it will attack over to H plus, and Br comes out. So it will be like double bond is now a single bond. H positive approach over here, one bond. Br negative will approach over here. After that, simultaneously I have created the two in a similar single reaction. Getting it or not? Now to symmetric alkene. These all are symmetric alkenes, so wherever we can add. But if we need to attack it over to unsymmetrical alkene, then we have to consider it in a way that CH3, CH, CH2, HBr, H positive. So over here, what actually happens is double bond migrates over to the position where we are getting a stable carbocation because this will migrate the bond over here. CH3, CH positive, CH2, and this CH2 getting a negative charge, and that negative will be approached by H positive. Right? HBr release what? HBr produces H positive. First of all, that is very reactive and will automatically this will add over here, and we are getting 2-degree carbocation, secondary carbocation. Right or no?
Yes, ma'am.
So we are getting a secondary carbocation, 2-degree carbocation. Now this secondary carbocation is ultimately attacked by Br negative, and it will be forming structure to be like. That is why we are forming this to be as major part, because it is 2-degree carbocation which is stable. If you migrate it in opposite direction like this, then you will get a 1-degree carbocation. That is unstable. That is why this bond migration will not happen. Got it? So this is Markovnikov's rule, but I honestly say to my students that do not follow Markovnikov's rule because many a times it will not be as such Markovnikov which is happening. Because Markovnikov rule, what is Markovnikov rule? Add negative part of its name is addendum. Means adding reagent, attacking molecule. So negative part of addendum attacking molecule to the double bonded carbon. It contains less hydrogen. That double bonded carbon which contains less hydrogen. And positive part you have to add of addendum which attack to that double bonded carbon having more hydrogen. Okay? But the point is that due to we know that carbocation is formed. So there might be possibility in some example that carbocation undergo rearrangement. Got it?
Ma'am, only in the alkene this rule has been followed, ma'am. This Markovnikov rule.
Only in alkene. Huh?
Only in alkenes, only in unsymmetrical alkenes and addition only we will follow this Markovnikov rule. You are saying.
See, it also mentioned that Markovnikov rule, but I will suggest that do not follow this rule anywhere. It's just in your syllabus, so I have written over here Markovnikov rule, but usually it's like due to rearrangement, na, Manch, there might be the changes as well. I'll take an example to explain you in more detail. Let's see. Let's say this is the alkene. We are adding HBr. According to Markovnikov rule, if we apply over here, we will be getting this type of over here H and over here Br. Actually, this is not the correct product. Correct product. Actually, what happens is, see, as we add HBr to it, first of all, we will form a stable carbocation. Get a positive charge. Now, this 2-degree carbocation, there might be 1,2 methyl shift. There will be 1,2 methyl shift. During shift, we are getting a more stable carbocation. 3-degree carbocation we are getting. Got it, na, Himansh?
And to stabilize it again, that 1-2 shift will
Now,
occur.
yeah, now I will give you that. Oh, we are negative part. We are negative will attack to stabilize that positive. So now we will say this will be the final one, not this one. Is clear or no? Thank you. Can I show you an answer?
I'm clear, ma'am.
That is why application of Markovnikov rule is not always justified, because if you do Markovnikov rule, this will come from what we are getting, but this is not the actual product. We'll see. This is not the actual product. Actual product is this one. Got it?
And because of 3 degree will be more stable, that's why we are saying that as the.
Yes, exactly. Okay.
Yes, ma'am.
So, um, let's discuss some example of this unsymmetric part. That is acid catalyzed hydration. Means we are adding water to an alcohol. See, now also if there is a possibility of rearrangement, you will go for any rearrangement, sort of rearrangement if possible. Got it? Because see, hydration. Hydration means we are adding water. Water in the presence of acid. H positive is present. H positive, but then we'll do what? Let's say bond migrates over here. This hydrogen will be attacking over here, and this carbon got a positive charge. Then water, oxygen have lone pair, so lone pair will attack over here to stabilize the carbocation, right, Himansh? And just see, now oxygen attacks over here, so oxygen got a positive charge. To stabilize that positive charge, now oxygen need to break a bond, right? Oxygen will take that electron, it will break a bond. Now the point is which bond it can break. So it will break the bond with hydrogen. Alright. Or no, because carbon cannot, it cannot break the bond with carbon because right now only oxygen attached with carbon. So that is the reason it cannot break the bond with, we can say, carbon.
Ma'am means here C plus and C minus will be formed. That minus will be this H plus will attack on that C minus and CH bond will be formed. Again, this water molecule oxygen giving its electron forming H2O positive. A bond is forming. We are going to say, ma'am. Yes, ma'am.
Is it clear or not, Himansh?
Ma'am, clear, ma'am.
So always remember, I'm writing over there that since carbocation is forming now, always remember whenever in a reaction carbocation forms now, Himansh, always go for rearrangement. Because
Whenever forms, we should go for most stable state of carbocation.
got it? Moving on to another example, second example, that is hydroboration oxidation of alkenes. Very important. Usually it asks that in your exams. Very important. Hydroboration oxidation reaction. So here, what actually it happens is, we are having with us an alkene. I'm forming an unsymmetrical alkene. So we are providing TH3 THF. THF is tetrahydrofurane. That is a solvent. What is THF? Tetrahydrofurane, that is a solvent. It's a solvent. So we are providing over here this. Now we are getting over here is the hydroboration oxidation. The second reagent that we attach is OH negative, that is the base, H2O2 peroxide and H2. It will follow anti-Markovnikov addition. Anti-Markovnikov addition. Anti-Markovnikov addition means against Markovnikov's rule, right? Opposite to Markovnikov's rule. So we are getting over here, we are over to this side. OH over to this side, we are attacking OH and this hydrogen over here. Anti means opposite to Markov. Anti is in the sense we have to follow the opposite of Markovnikov. So here H and here OH will come.
No need to remember this anti-Markovnikov rule.
So the second, you just have to remember this hydroboration. The second reagent that you provide over is CH3 double OH. So then the name is molded. That is a hydrocorrelation reduction. And you are getting CH3, CH2, COOH. And if we are providing in place of it AgNO3, then dimerization will come. Dimerization means we are getting a dimer. Means 3 carbon chain we are getting hexane we are getting. Basically what happens in the reaction, let's discuss about the mechanism of it. So we are having with us, let's say alkene. We are attacking BH3, right? BH3. So now the point is that BH3 is there, right? In BH3, boron is electron poor. Listen to me carefully. That boron is electron poor, due to which carbon, again in a similar manner, we are becoming the same type of carbocation. What happen is carbon get a negative charge. This carbon will approach to BH because BH is electron here because it's having 6 electron on it. That is the reason it will be forming CH3, CH, CH with a positive charge. This CH2, don't think about a carbocation which is forming over here. It will not create a carbocation. It is a simultaneous step. Means carbon give electron to boron, and boron, a hydrogen will come out and attack parallelly over to this carbon, H negative, hydride, H negative. Getting it? Much. Are you getting it or no? If it is carbocation, that is not correct for the reaction. It's no carbocation forming over here. Okay, bond will shift over here to this carbon CH2. When the CH2 get electron, it will transfer it to BH3 because boron is 6 electron species, it's electron pure, so it will accept the electron of CH2. But since boron electron accept electron from the CH2, it get a negative charge. So at that time in the hydrogen will remove out in the form of H minus. It will take that electron from the bond and transfer it to CH. So H2 is forming over here. Is it clear or no? Himansh, tell me.
Ma'am, can you explain this again? I'm not getting and clear.
No issue. I'll repeat that part for you. So we are having, let's say this is the structure. Right? BH. The H, one more H, BH3. This is BH3. I have opened an hydrogen. So here kind of a bond is forming like this. If you think about it, it's a bond forming in between CH to BH2 and one bond is forming between hydrogen and CH like this. So actually what happens now that CH2 take that electron density because obviously this carbon getting a positive is stable 2 degree carbocation. So CH2 get a negative charge and CH get a positive charge. And boron is electron poor, so it will take that electron of CH. Like I'll show you over here. That only happened. This carbon got a positive and this carbon got a negative charge. This negative will attack to BH because it is electron poor. So when let's say carbon attacks to BH2, it will form the structure to be like this. BH2, one more H. Now boron since take that electron from carbon, so it get a negative charge. This carbon got a positive charge. Is that clear to you or not? So,
Means carbon is giving its extra electron to BH, so that's why it's forming a bond and negative charges formed, we can say.
Now to overcome the negative charge on boron, now hydrogen will take that electron from boron, right?
Yes, H minus and again the CH will combine.
And now CH will combine with CH positive will combine with H minus, so it will be CH2 and CH2 and BH2 now. Got it? Is it clear or not now?
Yes, ma'am, clear now.
Okay? So we are getting what? Give me a second. Just okay. I'll explain the first of all update mechanism to you. Is it clear to you first step? Over here, Manch.
Yes, ma'am, this mechanism I understood, ma'am.
So this is the first step. Now, do it.
Ma'am, this is not the mechanism, no?
No, the mechanism of that. Actually, that is the splitting of a, we can say 3-4 steps I've shown to you. But over here, but actually, we will say that it's a parallel shift, simultaneous shift which happens over here. Getting it? Himansh? Himansh?
Means parallelly they are going on. Immediately we are seeing.
It's not like carbon. I've shown a positive charge, negative charge to you now. But actually, no positive and negative will form. It's parallelly all the steps going on in one go. We are not obtaining any intermediate of a carbocation or carbanion. No, we are not getting that. Got it? So now, again, this is the same bond moves over here. This boron is again electron poor because of 3 bond only. So again it will attack to, carbon will attack to boron, make a bond with boron, and hydrogen will go over here, this carbocation. Getting it or no? Himansh?
Yes, yes.
I think that you are confused now, right?
Means you're saying that immediately all these steps will occur in only one
In
process.
only one step it will happen.
All will happen, but in only single
Correct.
step it will go. That's the.
Correct. Now one more CH3 because one more boron hydrogen bond is present now. So one more CH3 will attack. One more alkene will attack. Again, just listen to me. Again, what will happen? Carbon will take that electron. Double bond carbon will take that electron. This carbon got a negative. This carbon got a positive charge. This negative will attack to boron because boron is electron poor. It's 6 electron only. So it will attack to boron. After that, hydrogen, because boron after taking electron get a negative charge, so it will remove the hydrogen in the form of H negative, and H negative will go to this CH positive. So we are getting 3 alkyls like this. Boron to be like this. Is it clear or no?
Yes, ma'am. Clear, ma'am.
So this is a tri-alkyl boron we are getting. What's a tri-alkyl? Tri-alkyl boron we are getting now. Now we have supplied H2O2 to it now. Just break this bond. OH, break this bond. OH, and break this bond. OH. Although there is no, we can say, you don't need to revise or learn the mechanism because it's directly you can apply the concept because there is no rearrangement at all happening over here. So you can directly create that final products. No issues about it. But for your HTTP, okay. Got it? It's well managed.
Yes, ma'am. Clear, ma'am.
This helps. First of all, we can say anti-Markovnikov addition and syn addition. Syn addition means both H and OH occurs, we can say attack from the same side. Is it clear?
Yes, ma'am. Clear, ma'am.
I'm just saving it, okay, Manch? So isn't it look like it is anti-Markovnikov? If you compare it from the product to the reactant, you will get to know that OH attacks to the carbon which contains more hydrogen and H to the one which contains less hydrogen. Correct, Manch?
Yes, ma'am.
Also, remember anti-Markovnikov rule. I'll explain over here, okay? Anti-Markovnikov rule. Man, give me a second.
Ma'am, your voice is not audible, ma'am.
Can you hear me now, Imanj?
Yes, ma'am, now I can hear you, ma'am.
We haven't discussed anti-Markovnikov rules, so anti-Markovnikov rules so far.
Ma'am, no, ma'am. Markovnikov, first time listening.
Anti-Markovnikov rule, what actually happen is opposite attack we are doing, right? Anti-Markovnikov rule is also known as peroxide effect or Karash effect. That is anti-Markovnikov against Markovnikov. So we are attacking the bromine from to the carbon where hydrogen is more and hydrogen to the carbon where hydrogen is less. Right? So this is the major product now. Another one will be the minor product. Is the minor product. So if we do the explanation, why is it happening? Peroxide can be anything. See, peroxide can be anything. It is not like peroxide is H2O2 only. It can be organic peroxide such as benzoyl peroxide, any of it. Benzoyl peroxide, any peroxide. Whenever written peroxide, so you just have to consider that you have to apply anti-Markovnikov rule only with HBr, not with any other. So actually what happens over here is the mechanism. Why is it so? See, there is a logical reason behind everything. So peroxide, whatever be the peroxide we are using, let's say we are using H2O. So now what happen is here, because oxygen-oxygen bond is single bond is very weak. So we are getting OH radicals like this. This radical will combine with this. See, HBr is also breaking. HBr is also breaking. H will be combining with this H radical from HBr. It is more reactive. So that is the reason H radical is more reactive, so it will instantly combine with it and create a Br radical. Now Br is a radical which is free because H is already busy in creating bond with OH radical. So that is the reason we are attacking now this alkene with this Br radical. This Br radical will combine to that part majorly, after which combination radical created is more stable. So this is if I attach Br over to this carbon, so radical newly generated radical is 2 degree radical, secondary. But if I attach this Br radical to CH, then the 1 degree radical will be generated, right or no? Manch. So if I attach Br radical over here, so I am getting what? I am getting this 1 degree radical. So this is 1 degree and this is 2 degree. So which is more stable out of the two? You tell me. Is more stable. Agree or no?
Yes, ma'am.
That is the reason this 2 degree is ultimately attacked by where that now H positive from another HBr, because ultimately its major aim is to get stabilized. So we will say that now this is further attached by HBr. HBr again H radical will be created and that H radical will be combined with this CH radical and we are getting this the major product. Right?
Yes, ma'am.
Now there might be question that why is it so that only with HBr it is happening? Getting the question? That not with HF, HCl, why is it not? Because when we are doing the reaction of HBr only, HBr reaction is exothermic. When HBr is reacting, Imanj, that reaction is exothermic. Possible. This is free radical mechanism. Possible. If we do the reaction with HF and HCl, so no radical mechanism happens because they are having a strong bond. Got it? Because they are endothermic. Got it or no?
Yes, ma'am, got it.
But why is it like not with HI? HI bond is very weak, so why is it not? In case of HI, homolysis is possible. Homolysis is possible. But the point over here is attack of I to alkene not possible. It is endothermic. So I combine with I radical to form I. So that is the reason it is not observed over here. Is it clear or no?
Ma'am, it's clear, ma'am.
Give me a second, Iman. Just stop. You have any doubt as of now?
Ma'am, no doubt, ma'am.
Moving on to, okay, also remember that stability is 3 degree, then 2 degree, and then 1 degree because of radical stability. Okay, stability of radical is 3 degree, then 2 degree, and then 1 degree. That is why we are observing this trend, right? Moving on to after hydroboration. Now the third one is hydroboration. After hydroboration, oxymercuration and demercuration. Oxymercuration, demercuration. In short form, we are writing it as OMDM. Oxymercuration, demercuration, OMDM. So we are having again alkene. Now we are attacking HgOAc twice. OAc means OCOCH. This is OAc. This is OAc. So we are attacking over here HgOAc, H2O, water, THF, tetrahydrofuran as solvent, NaBH4, OH negative. Okay, one more thing to add in the last case, in this example. See, usually these are very exceptions. Usually this is the part that the examiner asks. Now the point is that BH3 is the one that provides what's it? Hydrogen, or it provide hydrogen, no? Means we can say note point over here is BH3 as we discuss the mechanism. BH3 is the source of hydrogen. Source of hydrogen. Provide hydrogen. And H2O2 provide OH. Correct or no? Manch?
Yes, ma'am. Correct, ma'am.
It provides us OH. Remember that whenever if any type of isotope of hydrogen will supply, like in case of BH3 they write B3. So you just have to replace, in place of hydrogen you have to write deuterium over here. But if OH negative or and H2O2, in place of H2O2 OH negative they are writing H2D2, right? So then you have to supply over here OD. Alright, got it? Is it clear or no, Himansh?
Yes, ma'am. It's clear, ma'am.
That is very widely asked according to isotopes stages. Now let's discuss about this reaction. This reaction is completely Markovnikov addition. H over here and OH over here. This is Markovnikov. This is for solving the Markovnikov rule. No real reason. So you can blindly follow the Markovnikov. No rearrangement. Okay. Now let's discuss about how the mechanism. You want me to explain the mechanism of it or no? That is only up to you.
Ma'am, in anti-Markovnikov, definitely there will be no rearrangement at all, ma'am.
Anti-Markovnikov, no rearrangement. Have a written it or not? No rearrangement. You want me to tell the mechanism of it or no?
Ma'am, can you explain the mechanism?
So mechanism is like CH3, CH, double bond, CH2. We are supplying HgOAc twice. So HgOAc twice. So what happens is OAc, again bond will migrate over here as I told you. Right? When the bond migrate over here, this carbon will attack over here. Because Hg is a metal. When it attacks over here, those OAc again leave out. But it contains lone pair as well. This Hg contains lone pair attack over here. Man, is it clear or no?
I'm clear, ma'am.
So now, first thing will be like, let's see, CH, CH2 attached with Hg. Hg got a positive charge because see, it taken the electron, it removes it out. Or from one end, it have taken the electron of CH2. But when it takes the electron, OAc leaves out. So now we can say there is balancing. But right, but Hg donate electron as well, so that is why Hg got a positive charge having OAc along with it. Like this. Now H2O is present now. Oxygen is having lone pair. So it attacks oppositely, the anti-addition. Oppositely it attacks. And when it attacks over here, why is it attacking over here, not over here? Because Hg is having a positive charge. So it wants to stabilize its positive by taking the electron. And it will take the electron from this carbon, because after taking the electron from this carbon got a positive charge, and this is 2-degree carbon. Right? So that is why it is taking the electron from 2-degree carbon, so that positive on carbon gets stabilized. And as the positive creates over here, OH2 means H2O, oxygen, will donate that electron to it. Is it clear or no, Himansh? Huh? What happened, Himansh?
It will take this because void will giving its electron to it. It will be more electronegativity.
No, no, no. See, when I'll explain to you, have a look. That Hg is having a positive charge, right, Himansh? Every species, charged species, wants to remove its charge. So Hg will try to take the electron. But now the point is, with whom Hg will take the electron? With which carbon link? From which carbon? This 2-degree carbon or this 1-degree carbon? So the answer is from 2-degree carbon, because when it takes the electron from 2-degree carbon, this carbon got a positive charge. And that is on 2-degree, which is stabilized. That is why Hg breaks this bond. Getting it or not? Whenever a charged species is there, it will eliminate the bond, it will break the bond, it will take that electron from that particular side, where after taking that electron, positive develop is getting stabilized. So this 2-degree carbon containing positive, after that donation, is stable. That is why bond is breaking in between 2-degree carbon and H. Because 2-degree carbon will then get a positive charge, and for 2-degree it's stabilizing on. Then after it, this oxygen having a lone pair, because we know that CH is getting a positive charge, so oxygen with the lone pair will donate the electron to us. Is it clear or not now?
And because of 2-degree,
Himansh?
means from 2-degree, even if it takes electron, it gets stable by taking electrons from oxygen. That's what we are saying.
Got it now?
Yes,
Okay, Himansh?
yes, ma'am, got.
So now the carbon taken electron from oxygen. Now oxygen got a positive because oxygen donated it, so it will take that hydrogen from one electron from hydrogen. Hydrogen comes out, so it will be like CH3V, CH, OH, CH2. Now see, to stabilize the this HgOAc is formed over here now. What happens now? This NaBH4 supplies H negative. Sodium borohydride. Hydride means H negative. So this H negative will attack over here. Okay. And it will be like this. Yes, Imanj, is it clear or no?
Yes, ma'am, it's clear, ma'am.
Clear? Zero is anti condition na? Because there was when OH attacks over here, H2O, OH attacks over here, it is oppositely attacked, oppositely, right? Because on the lower side already a ring is present, so it cannot attack from the lower end. So it have to attack opposite, so anti-addition, right? And regioselectivity means that it follows Markovnikov or anti-Markovnikov follows Markovnikovs without rearranging. Got it or no?
Yes, ma'am, got it.
So finding it out, you can ask me.
Ma'am, no doubt, ma'am, got it.
So now there might be any question like in the isotopic they frame the question like CH3, CH double bond CH2, right? And they are supplying over here NaBH4. In place of BH4, they are providing NaBD4. In place of hydrogen, deuterium is supplied H2O2 and OH minus. Okay, na? What will be the product that you will form over here? So NaBD4, don't be confused with it. NaBD4 means it will provide D negative. It will provide D negative. As I told you right now, NaBH4, it will provide H negative. So NaBD4 will provide D negative. So bond always moves over here. Bond always moves over here. So this carbon got a negative and this carbon got a positive charge. This positive will be supplied with this deuterium. So we are getting CH3, CH with deuterium and CH2. And CH2 will be supplied with this hydrogen from here, OH from here. OH from. Got it now or no? Himansh, any problem?
Ma'am, no problem, ma'am, got it.
Let's say we are providing PD and PD CHF and H2O2 OH negative. Now we know that BD3 provides deuterium. Remember I told you in hydrocorration oxidation. It will provide deuterium. And this is Markovnikov or anti-Markovnikov? What say? Hydrocorration oxidation. Whether it is Markovnikov or anti-Markovnikov, Himansh?
Anti-Markovnikov, you can say.
Anti-Markovnikov. So group hydrocarbon over to this carbon. Although it is anti-Markovnikov, so don't need to think about it. Just simply apply anti-Markovnikov's rule. Anti-Markovnikov is like CH3, CH. Okay, tell me what you will form. Yes, Himansh?
Ma'am, getting. I mean, D will be here and
He will be
For the CH2 it will attach now. I can say D will attach.
E. And here it is OH then.
Yes, my negative group over.
And what is anti-Markovnikov's rule? Tell me.
No, reverse it will happen. So, no.
Ah,
It's,
that is why I asked you to do this. Okay?
yes, ma'am. Okay.
See, it's very new for you, right? So when you revise the part now, you will automatically able to do this type of questions. But you require revision for it. Right, Ivansh? If I give you one more question, let's say this is the question. Now what we will form?
Ma'am, that carbon will go. Ma'am, C plus and C minus will be formed on there. Ma'am, for carbon attaching Me, we get C positive C.
First of all, just remind you, remember this Markovnikov and anti-Markovnikov. What's hydroboration oxidation?
I'm anti-Markovnikov.
Anti-Markovnikov,
Yes, ma'am.
what is why anti-Markovnikov?
Ma'am, my H will be on that carbon. It's negative. And the B will attach on this methyl carbon, we can say now, ma'am.
What thing? What to attach? Hydrogen
Yes, ma'am.
or OH over here?
Yes, ma'am. Watch over here.
Correct. Anti-Markovnikov, what is anti-Markovnikov? Positive part will attack over the carbon where the hydrogen is less, and negative will put over the carbon where the hydrogen is more. Right, Naiman?
Yes, ma'am. Right, ma'am. Good.
Okay. So, in hydroboration, oxidation, and oxymercuration, demercuration, you know why there is mercuration and why is it demercuration? Mercuration because the first step mercury is added, right? It's mercuration. In the last step, this one mercury is removed, so this is demercuration. This is mercuration because mercury is added. This is means demercuration, which is mercury is removed. Okay.
Yes, ma'am. Okay, ma'am.
me that amount, 2500. I don't know.
Today I will pay.
You asked me. You was asking me for one more class. You want to take it or no?
Yes, ma'am, for the doubts on and some.
Huh? You want to take one more class then?
Yes, ma'am.
Okay, you told me that you will update me how many classes schedule for that as well.
Ma'am, today I will update, ma'am. Yes, ma'am.
So
Yes, ma'am.
update and accordingly I'll schedule and pay that amount as well.
Yes, ma'am. Okay, ma'am.
Moving on to addition of halogens. Addition of halogens. So if over here we are getting any alkene, we are adding one molecule of halogen. Halogen can be either bromine, chlorine. Usually we are taking this. The presence of CCl4 as a solvent, non-polar solvent, to form vicinal dihalides. This vicinal dihalides. Okay. So now what actually happens over here? Let's discuss about the mechanism that operates over here. First of all, if the bromine we are taking up, bromine is it's having red brown color. Red brown color. So the red brown color during the reaction will disappear. Right? Due to this disappearance of the color, we can say red brown color disappearance. We will say that it's used. This reaction is used for the testing of unsaturation. It's a test of unsaturation. Okay. So bromine water test, usually we name it as bromine water test. So let's discuss about the mechanism that operates over here, right? So let's say we are having an alkene. We are adding bromine to it. So bromine addition is like this double bond given to bromine, bromine, other bromine leaves out. So it's like a cyclic 3-membered halogen containing ring is forming. This is known as cyclic halonium ion. Cyclic halonium ion. Okay. This halonium, Br negative removes out over here. So this Br negative which removes out over here will be attacking over to the any carbon. Whatever, as I told you, this bromine is getting a positive charge, right?
Ma'am, ma'am, bromine Br2 will form Br plus and Br minus, ma'am. Why, ma'am? Because both.
Both are same only, huh? Since you have both are same only. But actually the point is over here that it's like due to that alkene, alkene is doing heterolytic fission. There is no source of homolysis over here. If any peroxide, anything like that given to you, na? So peroxide are radical initiators. Got it, Himanshu? So they will initiate the radical mechanism, peroxides. But here, no initiator of that is present. So if one heterolytic fission is happening over here, so it will induce the heterolytic fission itself in this Br2 as well. Even if both Br are same only. But it is not like, remember when I told you about homolytic heterolytic fission that It's not always necessary that homolysis will always happen in the similar kind of molecule, like a molecule containing both the atom to be same. It's not always be the condition. Also, heterolytic is also not necessary that it is always happening in the different molecule. In the same molecule containing same atom can also do homolytic as well as heterolytic. Molecule containing different atom can also do homolytic as well as heterolytic fission. Got it?
Yes, ma'am. Got it, ma'am.
So pH will development C na? It will induce the heterolysis in DNA. Alright, Naimansh. Any problem so far?
Ma'am, no problem.
Now this carbon bromine got a positive charge, cyclohexyl ion. So here a positive charge is present, right? Due to this positive, what happens? Bromine break a bond with carbon, take that electron. See, whenever I create an arrow, that means electron shifted to that. In organic, wherever we show the arrow means that is the direction of electron shifting. So if I draw this type of arrow, that means electron migrate from the bond towards bromine. So here carbon got a positive charge. This will be attacked by bromine negative now. So it will be forming a structure to be like carbon over here having a bromine, the carbon over here having a bromine like this. So they both are anti to each other, anti-addition. Getting it? Vansh, clear or no?
Ma'am,
Huh? What happened?
ma'am, can you explain this again in this mechanism?
Last one. This one.
Yes, ma'am. Meant actually, ma'am, because of the presence of the CCl4, we are seeing,
This liquid is just a solvent. Nothing else is there with it.
ma'am, meant because of presence of this CCl4, we are saying that this Br2 is getting converted to Br plus and Br minus, ma'am.
CCl4 is nothing to do with that. See, CCl4 is just a non-polar solvent and it is just like we require solvent during a reaction, right? Solvent is a medium of, we can say, communication between the reactants molecule. So it's just like solvent. It is not itself participating. Non-polar solvent, CCl4 is a non-polar solvent because why I have written CCl4, I'll explain in the next part. But right now, CCl plays no role over here. If we use water, then water will influence something else. I'll explain in the next part only about what is the role of H2O. If you use H2O, what changes it will do. But CCl4, just remember that it is a non-polar solvent, it will not at all interact with it. Okay?
Yes, ma'am. Okay, ma'am.
Where are you confused? Tell me.
And generally, ma'am, this Br plus and minus converts, and this Br positive will form a bond in like this structure we are gonna say, na, ma'am.
Correct. Double bond, shift over one carbon. That carbon give electron to bromine. If you want me to explain it in detail, I'll explain you, no issues. See, this is the situation. Br2. Bond migrates over here, let's say. Right? This carbon got a negative charge and this carbon got a positive charge. This negative attacks to this bromine and this Br leaves out by taking the electron. So we're getting what? Carbon with the positive. This carbon attacks to bromine and this Br removes out, Br negative. Like this. Now, this bromine also have lone pair of electron, isn't that? So this bromine will attack to this C positive, carbocation positive. So it will create the structure like Br attack over here, so we are got a positive charge. That is how we are getting this three-membered halogen ion. Is it clear now?
Yes, ma'am.
Devansh?
Ma'am, yes, ma'am, it's clear, ma'am.
In this step, how does it I can't hear you, Ansh.
Ma'am, clear, ma'am. Hello, ma'am.
Yeah, hello.
Ma'am, clear,
So I
ma'am.
think the class as well, Ansh.
Ma'am, what, ma'am?
You are attending any other classes as well, or your maths or physics or any other classes?
Yes, ma'am, I'm having, ma'am, today.
Which physics class? Or maths?
Ma'am, today physics is there, ma'am.
Physics is there.
Yes,
At
ma'am.
which time?
Ma'am, I'll try to today 6 and 7:30 to 8:30, ma'am. Two will be, ma'am.
Two classes are there of physics.
Yes, ma'am. Today, Sir will take doubt session. That's right, too.
See, if you want to attend that outline class only now, so I'm having today's start to be free at 3 o'clock timing. So if you want to take, just update me and accordingly I will schedule your outline class as well.
Yes, ma'am.
If you have doubt.
Yes, ma'am. Okay, ma'am.
Okay. So this is and any doubt till now, much?
Ma'am, no doubt, ma'am. Up to.
Okay. So always remember we have to add it NT to each other. Like let's say we are having whenever we are having, let's say this is the structure given to you and you are adding bromine CCl4. So you have to attack it in NT manner. Means one bromine over here and another bromine NT to it like this. Alright.
Ma'am, why, ma'am, in general in an anti manner? Like,
NT is in the manner because since you can clearly see over here that the bottom side, right? If let's say these are the bonds over here, let's say, just consider it that this is a type of like these two bonds are coming towards you and these two are coming, these two are moving away from you. Okay, so this is a kind of a, we can say this is the arrangement of this carbon. Right, this carbon over here attached with carbon attached over here and like this two bonds over here. Right, so now either opposite or bottom. Since bottom side is already occupied by this bromine, right? This bromine is already occupying the bottom side. So from where this Br negative will attack? Obviously from the opposite end only. Isn't that?
yes, ma'am.
That is the reason if one bromine is on the bottom side, so another bromine is on top side. So that is why we are getting NT attack. Because both of them cannot parallel come. Because this bromine have to attack over here only. If it attacks from bottom side, it also will become. Got it? No, no.
Yes, ma'am. Got it, ma'am.
No. So this is how you are making the structure. Now, as I told you, what will happen if we are in place of taking CCl4 in presence of non-polar solvent? Br2 in H2. Let's say in polar solvent. Polar solvent. That is water. Now what will happen much? So here we are having alkene. Again we are taking bromine. In a similar basis attacking over here, bromine comes out. So we are getting what? carbon. If you want me to draw that structure only, I will explain from that only. So here we are getting bromine positive. Now after this, since H2 is also present, bromine is also present, negative bromine also present. But out of these two, H2 oxygen lone pair are more willing to attack as compared to Pr negative. Right? H2O or ROH, whatever be the condition is, ROH or H2O, oxygen lone pair are willing, not the bromine, because it's a halogen. Getting it?
Yes, ma'am, getting, ma'am.
So now bromine will take that electron as usual because it wants to stabilize the positive charge because it is unstable strain ring, hallonium ion, cyclic hallonium ion. So now the electron will be attacked from the oxygen lone pair and we are getting this carbon-carbon, this structure. We are over here and OH or OR, whatever we are attacking over here on the opposite side like this. Yes, we are getting that as well. It's not like we are not getting dihalo. Vicinal as well we will get, but in the minor quantity. Major product is this one. H2 OH will attack over it. Getting it?
Yes, ma'am, getting, ma'am.
In presence of, let's say, if we are having presence of Br2, in presence of NaCl, if we are attacking NaCl, that is aqueous. Now, what are the different possibilities we will get? We can get bromine OH because it is aqueous. We can get bromine Br2. We can get bromine and ClS2. Okay.
Yes, ma'am, got it, ma'am.
Depending upon what are attacking on. That is why I told you that depending upon different things, we can have that. Now let's see the attack of. Any doubt as of now, Himansh?
Ma'am, no doubt, ma'am.
RCOCO. After this, you want this PDF?
Ma'am, yes, ma'am, can you share this PDF, ma'am?
Sure. You also texted me to send the chemical bending as well, right?
Yes, ma'am, chemical, ma'am.
I will share that as well. ROCL. RCOCL. Now, RCOCL means C. How can we say about it? So, accordingly, the bond will be breakdown between the two. Cl negative and positive. Right? They are in the presence of AlCl3, they are forming this. Because usually the bond is not easily broken up, but AlCl3 is a good halide acceptor. It's a good halide acceptor. Always remember. AlCl3 is 6 electron species only, right? So it will take that electron from chlorine. Chlorine will be, we will get this carbon to be positive and chlorine to be negative. So CH2, Cl over here and COR over here. Getting it?
Yes, ma'am, getting, ma'am.
Yes, Himansh.
Yes, ma'am, getting, ma'am.
Similarly, S2Cl2 addition of S2Cl2. Although these are very rare to be asked, but yes, given that, so I'm getting them as well. S2Cl2. S2Cl2 when attacks over here, it will be creating the structure mustard gas or war gas. How? Cl, CH2, CH2, S, CH2, CH2, Cl, and one S will be out. And this is mustard gas. This is mustard gas. You can move now. Addition of carbene. What is carbene? Very important. This is one is very important. One is what is carbene? So basically, C. Carbene is C. This is carbene. We haven't discussed about carbene so far, isn't that? Himansh.
Ma'am, no, ma'am, I have not seen about addition of carbon.
Positive. So basically, this is diazomethane. Diazomethane. So carbon is having a negative and nitrogen is having a positive charge. So nitrogen leaves out. By taking the electron from carbon, it will leave out in the form of N2 and the CH2. Negative means also it contains an electron pair, right? Negative means what? Negative means it contains an electron pair. That is why it's having a negative charge. Nitrogen over here taken the electron of the bond. So that means carbon already contains that lone pair, but yes, this bond is removed out. So that is why carbon positive charge just removes now. So this is carbon. This is carbene. Is it clear or no? What is carbene?
From diazomethane we can.
Diazomethane, we have removed the nitrogen out. Due to which carbon which was having a negative charge is not having it now. What happened, Imansh?
Yes, ma'am, got it, ma'am.
Any doubt you are having in any set?
Ma'am, no doubt, ma'am, got it.
So tell me that carbene is electron rich or electron poor, electron stable, or what electron precise? What can you say about it?
No, it's a neutral means it can exist in a stable state, ma'am. But ma'am, since it's an intermediate, ma'am, we can say that it's needed to form bonds. It will be readily, we can say.
No, I'm not asking you that about vacuum. I'm asking that right now in current situation it is having how much electron in its overall, like how much electron it contains.
Electron. Ma'am, now it contains 4 electrons. May it will be stable now, ma'am.
Now it is having 6 electrons. 1, 2, 3,
3, 4,
4.
5, 6,
Because in
ma'am.
the valence, but 2
2 in a
shared.
bonding, yes, ma'am.
6 electrons. So it is electron deficient. Right na?
Yes, ma'am. So it's needed to form bonds.
Exactly. Although it is neutral. Neutral is because carbon have 4 electron in the valence. That is why it is neutral. But it is not stable because it is having only 6 electron in the, we can say, after sharing. Correct na, Himansh?
Yes, ma'am. Correct, ma'am. Good.
having an alkene. Let's say we are having an alkene. One second, let me save it first. Oh, we are run up with the time as well. Yeah, we did that. You are, I guess, very terrified with the chemistry, organic chemistry, right, Imanj?